Welcome back to Aurora Tech channel. Today, we're testing out something a little different, a 2.5D printer. Yes, you heard that right, not 3D, but 2.5D. This is the EufyMake E1, which I'd describe as a hybrid between a UV printer and a 3D printer. As you may know, a UV printer functions like an inkjet printer, but instead of regular ink, it uses UV curable ink. This ink is somewhat similar to resin, both are cured with UV light, but UV ink is much thinner and designed to work with inkjet print heads. When the ink is deposited and cured almost instantly with UV light, it allows printing on a wide variety of surfaces. This printer also comes with a moving Z-axis, similar to a 3D printer. This feature allows it to print one layer, cure it, then lower the bed to add another layer on top, gradually building up depth. As a result, you can create 3D relief textures or images. The 3D effect can be automatically generated by the software. All you need is a standard image or a design from their artwork library, which you can customize. The embossed print height can reach up to 5 millimeters, so I'd say it falls somewhere between 2D and 3D as a 2.5D UV printer. In addition, it incorporates some features found in laser engravers, such as a built-in 8-megapixel camera that lets you preview and position your job directly on the material. It also supports automatic height detection. You can basically print on anything that fits inside the machine, which weighs less than 1.5 kilograms, or about 3.3 pounds. The working area for the mini bed is 333 by 88 millimeters, and when using this bed, the machine is fully enclosed. For larger materials, you can switch to a larger bed, which extends the working area to 333 by 418 millimeters. With the rotary roller attachment, you can print on cylindrical objects like mugs, similar to how a laser engraver works. Generally, UV printers can be prone to clogging, especially if they're not used regularly or properly maintained. The E1 addresses this with a built-in cleaning system that automatically moisturizes the print head to keep it in good condition. I'd like to thank EufyMake for sending us this machine and sponsoring today's video. As always, even though this is a sponsored video, we won't hesitate to point out the cons of this machine. With that said, let's get started. The machine arrived in a shipping box that protects the retail box inside. The top of the box lifts off, making it easy to remove the machine. In addition to the printer, it also includes an extension bed, allowing you to work with larger materials. The extension bed resembles a 3D printer bed and features 2 linear rods on the bottom. By default, the mini bed is pre-installed. There's a white sticky sheet on top that you should keep on for calibration and the initial test print. I just peeled off a corner to take a look. The larger bed for the extension also has the same sticky surface to ensure your material stays in place during printing. As for the ink, the set includes the 4 standard colors you'd find in a regular inkjet printer. However, since we're not just printing on white paper, the machine also comes with a white cartridge to print a base layer on non-white materials. There's another cartridge labeled G for glossy ink, which adds a shiny finish to your prints. Additionally, it includes a cleaning cartridge. Installing the cartridges is straightforward, just like with a typical inkjet printer. Insert them one by one, making sure to push each down until you hear a click. The cleaning cartridge goes on the right side of the printer. Once you open the cover, you'll see 3 red protective caps. Remove them and insert the cartridge. After setup, install the app, add the printer, and let it run a self-test. It will load the ink and print a test pattern, just like a regular inkjet. If the results look good, you're done. If not, clean the print head or a specific color which is not good and reprint the pattern. It will then print some alignment code for camera alignment, and that's it. Finally, you'll be prompted to choose an example print. I selected the kitten, and the machine began printing. At first, I found it difficult to film the printing process because the covers are dark, but in later tests, I figured out how to record it properly, and I'll show you that in the upcoming sections. So far, everything seems to be working fine. The example print is a 2.5D image, and you can really see the cat pop off the surface. Let's start a real job and see how the software performs. I'll begin with a simple task, printing some text on one of my camera chargers. I'll print the text in this specific area using the PC software and take a snapshot. The machine will check the material height and return an image to the software. The software says this process takes 90 seconds, but let's time it. It actually took exactly 1 minute to measure the height and return the image. Next, I'll use the built-in text tool to type some simple text and position it. For the ink mode, since I just want to print white text on a black surface, I'll go with the simplest option, single layer white ink. I'll select print and leave all settings at their defaults, then start the job. The software includes an ink estimate dialog. As you can see, for this print, it only uses white ink, less than 0.01 milliliters, and doesn't use any other colors. Now let's go to the machine and start the job. For a simple job like this, it shouldn't take long. I'll also time it, including the prep time before it begins. The prep time took a little over 1 minute. The actual printing time was about 35 seconds. So, the total time from pressing start to completion was approximately 1 minute and 55 seconds. The phone app showed the same time, but the PC software only displayed the time in minutes without seconds. The result looks great and used almost no ink. With a better font and a smaller size, the text could easily look like it was originally part of the product. Next, I'll try printing on a transparent plastic box that I plan to use for storing USB drives and memory cards. As before, I'll measure the height of the surface and take a snapshot for calibration. This time, I'll also experiment with the AI image generation tool to create a custom design to print. Each AI-generated image costs 1 credit, but you receive 200 free credits per month. After trying a few different prompt combinations, I decided to go with a colorful design that complements the transparent material. I cropped and scaled the image to fit the surface of the box. For the material, I selected plastic and kept the print quality at standard. Since the box is transparent, I chose the white plus CMYK ink mode to print a white layer underneath the color image for better visibility. After clicking print, the job is sent to the printer. Let's check the ink estimate before starting. It uses 0.01 to 0.03 milliliters for each of the 4 color inks and about 0.38 milliliters of white ink for the bottom layer. The print completed in about 6 minutes. The colors look great, and there's minimal difference compared to the original image. On the back, you can clearly see the white underlayer printed beneath the design, which helps it stand out on the transparent surface. Next, I'll try printing on a ceramic tile. I've chosen this cute grumpy baby dragon image. Since the tile is white, I can simply use the simple color mode and print the color directly on top. For material type, I'll select ceramics. Let's send it to the printer and check the ink estimate. It uses less than 0.01 milliliters of each color and doesn't require any white or glossy ink. The job finishes in about 2 minutes, and the print looks great. Now I'll print the same image again, using the 2.5D relief effect to compare. I'll let the software generate the relief for me, which costs 1 credit. The preview shows some added 3D effect. In relief mode, you can set the thickness up to 5 millimeters, but I'll keep it at 2.5 millimeters to save time and ink. I'll leave smoothness at the default setting. For ink mode, color raised is the only option available in relief printing. After clicking print, I check the ink estimate. Like the 2D version, all 4 color inks still use less than 0.01 milliliters, but this mode also uses white and glossy ink to build up the raised layers. In total, this job will use about 3 milliliters of ink. As expected, it uses the white and glossy inks to build the height, then applies the color layer on top. This job took 34 minutes, which is about 17 times longer than the 2D version. Let's do a side-by-side comparison. If you didn't have a reference, the 2-dimensional print looks good, but the relief version clearly looks much better, even though it uses significantly more ink and time. The hair in the middle stands out as the highest part of the image, and the cracks in the eggshell are also beautifully printed. I'll also test printing on a camera lens cap. Since the surface isn't flat, there's a height variation of around 5 to 6 millimeters from the highest to lowest point. I want to see how well this machine handles that kind of depth difference. I'll use 2D print mode with a white bottom layer and a glossy finish, but I won't print in relief mode as it would interfere with the spring-loaded pinch mechanism of the cap. The total ink estimate is around 0.12 milliliters, including all layers. The print took 9 minutes, and surprisingly, it came out quite well. I don't see any major issues in the lower areas compared to the raised sections. Even in a spot that's about 6 millimeters lower, the image looks only slightly less sharp under close inspection, but from a normal viewing distance, the difference is barely noticeable. The lower area at the top edge also shows similar results, slightly softer but still very acceptable. I didn't expect this print to be usable with such a large height difference, but it actually worked. Next, I'll try printing on a phone case. EufyMake sent me a few blank cases specifically for testing, so I'll start with one of theirs. I noticed that this particular case is completely flat and offers no protection around the camera area. Personally, I'd usually choose a case with raised edges like the one I already use, but don't worry, I'll test both types. For this test, I used the AI image tool to generate a crocodile leather texture, but it turned out to be a mistake, and I'll explain why in a moment. I let the software generate a 3D relief, selected plastic as the material, and set the thickness to 1 millimeter, since people generally don't want their phone cases to become too bulky. Let's check the ink estimate. It comes out to 6.72 milliliters, with most of the ink being white and glossy, similar to other relief prints where these inks are used to build up the raised layers. You'll notice a large patch of white on the design. That's the mistake I mentioned. The AI-generated crocodile leather texture included shiny highlights, which the printer interpreted and reproduced using white ink. The print took 42 minutes, but the result looked strange with the reflective areas. To fix it, I printed a second layer of black ink over the entire case. I went back to the software, added a solid black shape over the case, and selected CMYK plus varnish for a glossy top finish. This second pass used only 0.08 milliliters of ink, and as expected, it covered the unintended white spots nicely. The shiny effect you see now is just from the lighting, not from white ink. Next, I tried printing the same design on my own phone case, which includes a raised area around the camera. I used the same relief and print settings. As with the previous print, the shiny white areas appeared again. So I applied the black overlay layer once more. This print also turned out great. When comparing both side by side, they both look fine, but personally I prefer my own case. The texture feels deeper and more refined. Since the printer handled the camera lens cap with a 5 to 6 millimeter height difference, I figured it should be able to handle a golf ball too. I decided to print my simple logo on it. Because the golf ball is already white, I can print directly with the ink and select CMYK mode without a white base. I selected plastic as the material and set the quality to high. The ink usage was less than 0.01 milliliters. The job took about 2 minutes to finish. The logo came out clean and sharp on the golf ball, and I didn't encounter any issues printing on a curved surface like this. Next, I'll try the large bed and start with a piece of acrylic. This acrylic sheet from the material pack is designed for a light box. It's quite thin, about 1 millimeter thick. During the snapshot and height measurement process, I noticed when using the large bed, it takes much longer than the mini bed. The main reason seems to be that the machine has to scan the large bed section by section. I timed it, and the process jumped from about 60 seconds to 3 minutes. I decided to print a full color photo of myself on the acrylic. I selected acrylic as the material, set the quality to high, and enabled the white ink layer underneath since the material is transparent. Despite the size of the image, 145 millimeters by 195 millimeters, the ink usage is still relatively low. The total estimated ink use was around 2.3 milliliters. The print took 33 minutes to complete and looked very nice in the light box frame. It actually looks better when the light of the room is off. I then printed a relief version of the same image for comparison. The color ink usage stayed about the same, but the white and glossy inks increased significantly, pushing total usage to over 10 times that of the 2D version. Midway through the print, I noticed an issue. The print head was scratching across the surface. I decided to let it finish to see how it turned out. After 2 hours and 10 minutes, the job completed, but it was clear the print head had dragged black ink across the surface. It wasn't hard to figure out why. The 1mm acrylic sheet warped from repeated UV curing, causing uneven height and contact with the nozzle. To avoid that issue, I found a piece of wood from an old cigar box my dad was planning to throw away. It was sturdy and had a nice finish, so I resized the image to fit and changed the material setting to wood, keeping the other settings the same. With the smaller size, the ink usage dropped from 27 milliliters to 20 milliliters. The job finished in 1 hour and 40 minutes. This time, the thicker wood prevented warping, and the print head didn't drag anymore. However, I noticed the image was shifted downward slightly. In the software, I had positioned it in the center, but the final print was still off by a few millimeters. It seems that camera alignment on the large bed isn't as accurate as with the mini bed. Still, the relief version looked much more impressive than the 2D one. I printed an even larger image on a metal plate measuring 300 by 400 millimeters, nearly the full print area. I chose a photo of Helios. I'm actually in the photo too, so if you can spot me, leave a comment. I selected metal as the material, high quality, and enabled white plus CMYK plus gloss for maximum effect. However, the ink estimate showed only 0.22 milliliters, which clearly seemed incorrect. For comparison, my smaller 2D photo used 2.3 milliliters, so I suspected a software bug, though I hadn't seen it with other prints before. Despite the glitch, I started the print. It finished in just under 3 hours, and the result looked almost perfect, except for a noticeable alignment shift downward of at least 5 millimeters. I checked the software and saw that I had placed the image about 2 millimeters too low, but the final print shifted even more than that. To salvage the piece, I cropped the top portion of the original image and printed a strip at the top to fill in the missing area. This second job has a more accurate ink estimate of 0.2 milliliters, which aligns better with previous smaller prints. The strip took 14 minutes to print, and while it covered the gap, the result still isn't perfect. I won't say it's unnoticeable, especially since I knew the gap was there from the start, but it's less obvious than the original misaligned version. I'll also try printing some UV DTF stickers. These stickers have a protective surface that must be removed before printing. You need to peel it off very carefully, as the film is extremely thin. As you can see, I accidentally damaged the corner of the first sheet I tried. Printing on the sticker is similar to printing any other 2D image. However, in the material list, you won't see sticker as an option by default. You need to enable global ink mode, and then you'll find the sticker option at the bottom of the list. From there, the printing process is just like any other job. For this batch of 4 stickers, the estimated ink usage was about 1.14 milliliters. The print took 8 minutes to complete. Before using the stickers, you need to apply a protective film using a laminator. This device functions similarly to a regular laminator. Just preheat it and feed the sticker through. Once that's done, you can use the blade at the back of the machine to cut them out and trim the edges as needed. The final result looks like a normal sticker, but UV resistance. These stickers can be used on items that are too large or impractical to place inside the printer, such as skateboards, guitars, or cars. Finally, I tested the rotary roller. Once installed, the software automatically detects it, just like when switching between the mini and large beds. When I clicked auto measure, something really cool happened. The roller lifted and leveled the mug, then measured it automatically. Next, I selected the mug's shape and specified whether it had a handle. After scaling the image, the software displayed a preview of how it would appear on the curved surface. Once everything looked good, I started the print. The ink estimate was about 0.03 milliliters. The job took 23 minutes to complete. The result was a success, another cute grumpy dragon, and creating something like this using the software was surprisingly simple. Okay, let's talk about the pros and cons of this printer, starting with the pros. 1. This printer is significantly more affordable than professional-grade UV printers capable of 2.5D relief printing. For example, Epson's entry-level model, the SureColor V1070, offers a much smaller print area, up to A4. While the EufyMake E1 provides more than twice the printing area, yet the Epson still costs 4 to 5 times more at $8,500 if you're considering UV and 2.5D relief printing for business or want to expand your product line. You're essentially comparing a $2,000 investment to an $8,500 one. 2. As someone who has used Anker products for years, I expected solid build quality, and the E1 delivers. The machine feels well made and thoughtfully designed. You won't find the odd defects or cut corners that are often present on cheaper, unbranded alternatives. It's a machine you'll actually want to keep using. 3. Wide material compatibility. It can print on virtually anything: plastic, metal, wood, glass, stickers, you name it. EufyMake claims it supports over 300 materials, and I don't doubt that. Since it uses UV light to instantly cure the ink, I honestly can't list all 300 materials, but I also can't think of anything it can't print on. 4. User-friendly software. The software is extremely beginner-friendly. You can drag elements from the built-in library, use the AI tool to generate images, or upload your own designs. Most settings are preset. Just select your material and desired effect. The relief generator in particular performs surprisingly well, producing high-quality 2.5D prints automatically. 5. The rotary roller is the most advanced I've tested. I initially thought it was like a standard rotary attachment for laser engravers, but it goes further by automatically adjusting and leveling the object. I got a perfect result on my very first try. 6. Before starting a job, the software provides an ink usage estimate, a particularly useful feature for small businesses. It allows you to calculate material costs up front and price your products more accurately. For example, if a 2.5mm relief consumes too much ink, you can reduce it to 2mm or 1.5mm to achieve a similar effect while saving on ink. Additionally, the built-in self-cleaning system helps prevent UV ink clogs by automatically maintaining the print head, minimizing downtime, and ensuring consistent print quality. Now for the cons. 1. Like all UV printers, the UV ink has a resin-like odor, so it's best to place the machine in a well-ventilated space. When idle with all covers closed, or when printing with the mini bed, which fully encloses the machine, I barely notice any odor in my garage as long as there's some ventilation. However, when using the large bed, you need to open both the front and back of the machine, and that's when it gives off an odor similar to a resin printer. I've opened the back and connected it to my own laser engraver ducting setup, which works well for now. That said, it would be much better if the machine came with a built-in ducting adapter instead of just a filter. The internal filter may help a little, but definitely not enough to fully address the odor. 2. When the machine is idle, it automatically moisturizes the print head to prevent the UV ink from solidifying and causing clogs, which means it consumes a small amount of ink each day. I checked with EufyMake, and they confirmed it uses about 1 to 1.5 milliliters daily. So, if you don't plan to use it for a while, it's better to shut it down completely. The shutdown process takes about 15 minutes, during which the machine unloads ink and puts itself into storage mode. When you power it back on, it will inject ink and clean the print head, a process that also takes around 15 minutes. In other words, don't expect it to start printing immediately like a regular inkjet printer. 3. The snapshot camera works best for small objects placed directly at the center, similar to the ones found on laser engravers. When using the large bed, I noticed the alignment isn't as accurate as with the mini bed, likely because it scans the surface section by section. On 2 of my larger prints, the image was slightly shifted downward. 4. In the beta testing software, the ink estimate isn't always accurate. For example, when I printed a 300 by 400 millimeter image on a metal plate, the estimated ink usage was only 0.2 milliliters, which was clearly incorrect, especially considering that a much smaller image at just 25% of the size had previously been estimated at 2.3 milliliters. Accurate ink estimation is crucial, particularly for business use, where every drop counts. Currently, the ink level indicators are still under development and are just static icons serving as placeholders. EufyMake told me that their next software update in June will address this, hopefully including more accurate ink estimates. After all, even standard inkjet printers offer this basic functionality. 5. When using the same Epson V1070 for comparison, the EufyMake E1 is much cheaper for the machine cost. However, when it comes to ink costs, things get more complicated. A full set of original Epson cartridges, 8 250ml cartridges totaling 2,000 milliliters, cost about $560, or roughly 28 cents per milliliter. In comparison, the EufyMake E1 ink set includes 6 100ml bottles plus a 380ml cleaning cartridge. Its MSRP is $300, though early backers can get it for $179. I assume the cleaning cartridge worth $30 at the discounted rate. That comes out to roughly 25 cents per milliliter, slightly cheaper than Epson, still within reason. However, if the price increases to $300 after the campaign, it jumps to 45 cents per milliliter, making it even more expensive than Epson's original ink. It would be more reasonable if EufyMake priced the set closer to $200 after the campaign. That would keep the cost more aligned with Epson's per milliliter pricing. Personally, I find it hard to justify paying more for EufyMake's ink than Epson's. The highest price I'd be willing to pay is the same. In conclusion, my overall experience with the EufyMake E1 printer has been excellent. As someone with a background in 3D printing and laser engraving, I describe this machine as a unique blend of an inkjet printer, a resin 3D printer, and a laser engraver. The hardware is well built, and the software is intuitive and user-friendly. Even for those new to UV printing, it's easy to get started. While there are a few minor software bugs, as mentioned in the cons section, the printer still met my expectations, and I'm satisfied with the results. Their Kickstarter campaign is still ongoing, so there's still time to back the project if you're interested. With that said, keep in mind that Kickstarter comes with its own risks. Unlike buying an in-stock product, you'll need to wait longer to receive your order, which adds a layer of uncertainty. However, according to Anchor's public financial reports, the company had an annual revenue of $3.65 billion in 2024, so this isn't some small unknown startup. It's very unlikely that they would disappear like some failed Kickstarter projects have in the past. Some people might argue that Kickstarter is meant for small startups, not large companies of this size. But the reality is that Kickstarter is a public benefit corporation, and it's still a for-profit business. They take a cut from every project, so they're not a nonprofit purely here to help. In the case of this project, which already has over 10,000 backers and has raised nearly $28 million as of today, a 5% cut amounts to around $1.4 million going to Kickstarter. To me, it's just an online campaign platform, and it's up to them to decide which projects they choose to accept. What really matters is whether the product is solid and the company is trustworthy. I've included the link to their campaign and official website in the video description. Please also check out my website auroratechchannel.com, which monitors the prices of major 3D printer brands to help you find great deals. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.